Statistics with Mustafa. Today's lesson we're going to talk about a widely used test, parametric test, which is ANOVA, analysis of variance. We had practiced it before the student's test and the Wilcoxon, also the sign test, but now the analysis of variance is used to describe if there is or there are difference or significant differences of means between more than three or more than three groups. The ANOVA, or analysis of variance, contains three types or three main types. The first one is one-way ANOVA. Is used to describe if there is a significant influence of a factor on this continuous variable under the assumptions of under the three assumptions. The first one is the independence of observations. The second is normality of distribution, and the third one is refers or corresponds to the homogeneity of variance using the Levin's test. The second one type of Levin or of ANOVA test is the two-way ANOVA test. Two-way ANOVA test is used to explore the effect of two-factor inter-subject factors and their interaction. The third one is refers or corresponds to three-way ANOVA, is used to explore the combined effects of three-factor and including all two-way and three-way interactions. So using following these packages, Tidyverse, GPub, statics, and Datarium, and using the head function to show the first 6 rows of the iris dataset from the Datarium package. So iris contains 4 continuous variable, also known as a response variable, and one only independent variable, which is species. For example, if we want to check if there are a significant difference of means for example, between these groups, we should first of all check the assumptions. For example, we can assume that the independence there are an independence of observations, which means that for example, the subject or the individuals should belong to only one group. So in this case, the data doesn't, for example, have repeated measures in the samples, for example. So only or each subject or each individual should belong to only one group. So in this case, we can assume the independence of variance, or sorry, independence of observations. So move on to the next assumptions, which is checking the normality, for example, of distribution, taking, for example, sepal width as example. So sepal width is a dependent variable or response variable, and species, for example, is the independent variable or explanatory variable. So we want to check if there is a significant difference of between means of these three groups of species, which refers to Setosa, Virginica, versicolor. Using this command, we should write iris as data frame, percent more than percent, and group by, and write the species as data frame as the independent variable, and percent more than percent, and write Shapiro. So Shapiro test is used to check the normality of distribution of sepal width along the three kind of species, and select sepal dot width, for example. In this case, we have three non-significant p-value, which indicates that all groups follow a normal distribution. So we want to check the third assumptions, which is the homogeneity of variance using Levin's test. Following this structure, iris, percent, more than percent, sorry. Good. Use Levin test and put here first and the dependent variable, which is sepal width tilde species, and click to run. So also the p-value indicate that the there is there is a homogeneity of variance of each group, so we can assume that the variance between group is equal. In case when we have a significant difference, in this case we shouldn't uh, apply the standard ANOVA. When we have a significant variance or p-value, significant p-value after applying a test of Levene, we must apply a Welch t-test instead ANOVA or ANOVA classic test. But in our example, the assumption of homogeneity of variance is met. So move on to the applying of the ANOVA test using this structure iris percent more than percent ANOVA underscore test and write simple dot weight tilde species. The results of p-value of ANOVA test indicate that there is a significant difference between groups. But there is a twist. ANOVA tells us that there is only a difference significant, but we don't know which or between each group, for example, between Setosa and Virginica, or Virginica and Vescaler, or all groups, or for example, have a significant difference of means. So in this case, a p-value of or significant p-value of ANOVA should follow. In this case, we should follow up this significant p-value with a test of post-hoc or pairwise post-hoc or pairwise test to know what is the groups that, for example, show the difference between their means, because ANOVA only tells us there are a difference significant between means. But the pairwise test, in this case, we must use 2K HSD, which refers to honest significant difference, tells us uh, which groups, for example, have a difference between means. So using this following, using this command iris, running this command iris percent more than percent 2k underscore HSD, which refers to honest significant difference. So we follow up the significant value of p-value results of the ANOVA test by the pairwise test, and write the simple with tilde species. Sorry, species here. Very well. So this is the results of the pairwise t-test indicates that all groups shows the difference significant between means. So in this case, the results of ANOVA also indicates a 0.4. So this results indicates or corresponds to effect size. In this case, the species affect sepal wing with a 40%. So the variance of 40% of sepal wings is affected by the difference of species. This is how we can, for example, describe or interpret the results of effect size. And these results are this 4.49 multiplied by 10 raised to the power minus 17 refers to a significant p-value of ANOVA test, which refers that there is only significant difference. And so this significant difference should follow up by the test of post-hoc. In this case, we should apply 2K HSD test to verify a 2 by 2 group to verify if there is significant difference between each groups. After this, we want to, for example, draw the results of ANOVA test and 2K test in a figure. So this figure should be elegant and beautiful, ready to publish. So using this command, so first of all, let's give a name for this command here. for example, ANOVA equal to iris. So ANOVA in this case refers to the results of, or the output of the ANOVA test. And also the pairwise t-test, for example, we should assign a name for this comment, for example, post underscore ok equal to the comment refers to test of pairwise. So post doc results or corresponds to the results of the 2k honesty significant difference. After that, we want to create or visualize these results of postdoc and ANOVA in a box plot. In elegant box plot using this command. We should add the position of the postdoc test. For example, postdoc equal to postdoc, very well, percent more than percent, add underscore xy position, and put here x equal to, and between double quotation marks, the independent variable. Very well. After that, we can draw successfully a nice box plot using this function ggplot iris, which corresponds to our data sets, and aesthetics graphical, x equal to what? To species, comma, y to sepal length with uppercase, and comma, color, for example, equal to species plus geom box plot. Sorry. So this the results of distribution of each groups. The dependent variable is sepal length, and the independent variable is species, with 3 main groups. So we can add the results of ANOVA firstly, plus labs, subtitle here in the subtitle equal to get test label very well, get test label, and write it the name of this command, which is ANOVA, as named it, ANOVA, very well, comma, detailed equal to true. So this is the results of the test of ANOVA with the effect size, the p value, and the statistic f. And if you want to add which, for example, test of we have used to as pairwise test, we should only add this, for example, command here, comma, caption get pwc, very well, and write this one, postdoc refers to the command for computing the pairwise test, postdoc, very well, add stat p value manual, and here put the name of for example, postdoc. So here we can, I think, clearly, for example, in this case of setosa and versicolor, and virginica and setosa, and versicolor and virginica, we can clearly identify which groups differ significantly in their difference or in their means. So finally, if you have any questions or suggestions, please leave them in the comments below. This brings us to the end of this video. and I hope it was helpful or useful for you. Thanks for your watching and see you next time. Bye.